quite intensively.
Yeah, at this point, actually, what we believe is that path difference is absolutely zero because both the waves, both the light waves coming from the same source have to cover the same distance. So it's always a constructive interference. And this is the bright fringe of order number zero. Now, when you talk about order number one, remember that you're talking about distance from the central point. This is the order number one. This is the order number two. This is the order number three. And this is the order number four. So actually, you have to go from central fringe and then you're going on the top. So order, it means that the fringe number one, order number one, bright fringe will be just after zero fringe, the order number zero, then two will be right after the one. So you're going from middle to top. And if you're going from central fringe to the bottom, it will be all a negative, right? Any problem in
Yep.
this? That is very simple.
No.
Now, at this point of time, I told you previously that we are actually try to derivate an equation or something or formula to find out the distance between two bright fringes, consecutive or a dark fringe. Because what we believe is all the fringes are equally spaced. Like this is a bright fringe, this is a bright fringe. So we want to find out the distance between these two. Now, how do we do this? This is actually very important. For that reason, we have drawn this diagram. If you see that, this is the slit distance, D. One ray is going from that S1 to this point P, let's suppose, and one ray is coming from this S2 to that point at P. And this is the point Q right at the center, and this is the central point as well too. I mean 0. Now, if you see that, that makes a triangle. Now, if you see that, if I ask you what is the path difference, you can say to me previously d sine theta. We already discussed that, right? So basically, if you ask me path difference, then it is d sine theta. Or in other words, if you see that, we can say that I'm talking about this triangle. S1, S2, N. Triangle S1, S2, N. If you apply sine on that, it will be sine theta equal to. Now, this whole thing is technically called, this thing is called as n lambda divided by d. Can anybody tell me why did I write n lambda in this? Because it's a constructive interference. We are talking about the constructive interference. Initially, we will find out the distance between two consecutive bright fringe, and then we will do that for the non-bright fringe as well. I mean, dark fringe. That's the reason sine theta is equal to n lambda. I take this distance as n lambda divided by d. Now, if I apply a tangent formula here, I'm talking about this big triangle, triangle QPO or PQO, whatever. If I apply a tangent theta, because what we believe is this angle and this angle are equal. So, tangent theta is equal to. Now, let's see the diagram here. This is very important actually. What is this thing means? This distance YM means? Yes, Manur, what is this YM means? It is
The YM?
Yes, YM.
That's the opposite.
That's actually the distance of the mth fringe with respect to the central fringe. So, it is your distance of that, let's suppose, fringe you're talking about with respect to the central fringe. So, this is YM and divided by that distance, which is D in that case. So, you use S1, S2. Yeah, you're saying something?
The distance between fringes were already. Oh my god. So you always say distance between the fringes from the end of one to the end of the other one, right?
Yep.
It's not from the middle of the fringe.
No. You actually misunderstood that. Don't check what I'm saying. See, let's suppose you're talking about this is the center, right? Now,
Yeah.
let's suppose you're talking about this fringe, right? Now, the one which is very next to that is YM, or let's consider YM. Then the next one will be YM plus 1. The very next one will be YM plus 2. So technically, it's all you're adding up from this point. Now, this one will be Y1. This one will be, sorry, let me just have my pen so that you will understand. This is 0, right? This one will be YM. This one will be Y2. This one will be Y3. And this one will be Y4. Now, important point, to make your life easy, let's consider this one as YM. This is YM. Where will be ym plus 1? Definitely 1 on the top.
Above.
So how will you find out the difference? If you subtract ym plus 1 minus ym. Now you understand that?
Yeah.
Because actually we have to find this delta y in the end. Let's see how do we do that. So we consider this ym as just a length of your mth fringe, right? Now, I told you previously, but let's quickly see that. Let's take the angle, let's suppose at 15 degrees. Can you find sine 15 and tangent 15 at the same time? Check it out. What is the value coming up? Sine 15 and tangent 15. What are the values? You will see that the values will all.
0.26.
And what about sine?
No, that is sine.
Okay, then find the tangent.
Tan 15 is 0
0.27.
to
Are they almost same?
Yeah.
yes.
So remember that the theta which you considered here, the theta at which the line, I mean the angle between the theta, this one, or the theta at which the actually this ray is going towards the screen, we are actually believing or we are thinking that this theta value is very small. So if its value is very small, then it means that tangent theta is equal to sine theta, or in other words, n lambda by d is equal to ym upon d. Now, what is the value for ym now? Ym will be equal to n lambda d upon small d. So, this is one of the formula that if, for example, they will ask you what is the height of mth fringe with respect to the central point, this is one of the formula. N means number of order. M, it's not ym actually, it's yn, sorry, because we are considering everything as n. So you will place n here. Let's suppose you place n at the place of n, you are placing 2, then it will tell you height of the nth bright fringe with respect to the central fringe. Lambda will be the wavelength of the lambda wavelength, and d will be the separation between the screen and the slit, and small d will be separation between the two slits. Understood?
Yes.
Alicia?
Yes.
Okay. Now, once you reach to this point, what is our main target? We need to find out this delta y. For that reason, we already found out yn. Now, let's find out yn plus 1. How will you do this? Just place here, instead of n, just place here n plus 1. So, it will be lambda d upon small d. Now, how will you do this? The formula will be yn plus 1 minus yn. That will give you actually delta y, the change or the distance between two consecutive fringes. But technically, we are talking about the dark fringes. Remember that, please. Now, let's put the values. Yn plus 1 is n plus 1 times lambda d divided by small d minus n lambda d divided by small d. Now, lambda d upon d is common. What left inside is n plus 1 minus n. So, n and n cancel. What is the formula coming up? Lambda d upon small d. This is the formula for the bright fringe spacing. So, you actually know the different distance between the two, I mean, the slits and the central point, I mean, on the screen. D is the distance between two slits and lambda is the wavelength. If you know all these things, you can very easily find out the fringe spacing. But remember that we are for the time being talking about the bright fringe. Manur, I believe we have done this, so you understand that, right?
Yeah.
Okay. And what about you, Zoha and Alicia?
Yeah, I understand.
No.
Finding ym is just for the bright fringe.
Yeah, it's phi n actually, not m, because they use m, I am using n. Don't be confused with m and n, because we are using n continuously, so don't consider this as m. This is n. Now, my question to you is it bright fringe delta y and dark fringe delta y the same or the different?
I don't understand. Say again.
Again. My question is bright fringe spacing and dark fringe spacing. Are both the values same or the different?
I think they're the same.
They are same, and I can prove it to you. Let's check it out. We already have the formula yn, right? Now, let's do that. Instead of n, if it's a destructive interference, what shall I put it here? Mahnur, instead of n?
N+1.
N plus 1 by 2. And that will be lambda d upon small d. That is for the destructive interference, or you can say for the dark fringe, right? Now, this one is for the nth y value. Let's find out for n plus 1th. That will be n plus 1, which means 3 by 2 into lambda d upon small d. Same thing you do it, yn plus 1 minus yn, and that will be what? N plus, no, you will consider this as n plus 3 by 2 minus n minus 1 by 2, and you have lambda d upon d. So technically speaking, this n and this n cancel. 3 by 2 minus 1 by 2 will be 1. Again, it will be lambda d upon small d. Did you notice that you will get the same fringe spacing?
Yes.
So fringe spacing formula will always be same. The only formula will different is this one and this one. Just write these three formulas, because these three formula will be used while we will be solving the numericals. And Manur, you know what was a mistake last time? I noticed one thing. At center, what is the bright fringe? N is equal to 0, right?
Yeah.
For a dark fringe, if I plate n is equal to 0, will there be n is equal to 0 as a dark fringe? Possible.
No.
Now the question is it possible to have n is equal to 0 dark fringe?
Center, no.
No. That's what the point is. Technically speaking, if you're talking about n is equal to 0, this means order number 1. For the dark fringe I am talking about. When you say one value, order number 1 value, it means technically you are 1 value behind. If I say order number 2, it means n is equal to 2 for the dark fringe. If I say order number 3, for dark fringe, it is n is equal to 2 value. It's only and only for the bright fringe when your n is actually starting from 0 and your says 0th order and 1 order. But as in case of dark fringe, your 0 is basically your order number 1. I will tell you what exactly I wanted to say. Yes, everyone copied this?
Yeah.
Let's come to the question once again. The same questions which I have it, and I actually already if I don't pass it, we will finish it today. Okay. Let me just rub that. After this, we have a small topic that is called diffraction grading, and then we will go to the EM things, which are photoelectric effect. One of the very detailed topic, I have it. I will explain, inshallah, with you people. We will discuss that in too much detail. Then we have some atomic things and, all this annihilation, pair production and everything. Hopefully, we will finish this topic as soon as possible. Then we will have that mechanical thing and matters and everything. But after finishing this, I believe we better jump onto some past paper questions so that we will see how the things we had it already. Okay, now let's see. The questions are there. Where are the questions? Okay, we have done some of the questions, right? What my point is, what is the following on the slit is maximum, the fourth one. Okay, can you everyone try question number 4, please? By the way, which formula will you use in this? Question number 4?
Um, deconstructive interference formula.
No, this is not constructive. They say first minimum.
Yeah, D destructive.
So
I
what is it?
said deconstructive by
D,
accident.
D sine theta is equal
D
to
is equal to
n plus 1 by 2 lambda. Now,
yeah
any one of you tell me what value shall I put it here for n?
1.
No, that's what my point is.
Uh, that's 2.
That's 0. They say first. Remember that now. This is the trick of this question actually. Only and only n is equal to 0 will be in the bright fringe. There is no such thing called dark fringe at the center. When you take n is equal to 0 in dark fringe, it means you're talking about the first order. Now do that. What is the value coming up? And please make a habit of converting your all the values in the standard form. Otherwise, it will lead you to some confusion, and confusion lead you to mistake.
Is the answer 2.9 times 10 to the power negative 7? Or
Let's check it out. You mean this much? This is quite less, is it?
I also got the same
negative
answer.
7? Yeah.
Okay, let's do this. I mean, let's check. And what about you, Manu?
Same, sir.
Let's let me check if we got the same answer here. Okay, 4. By the way, 4 is not given here. Good to have it. Okay, no problem. Manu, do you remember which question was wrong? Which we actually, the answer, we got the wrong answer
Yeah,
in the last.
I have a picture of it.
Which one?
I have a picture of the question we got wrong.
Yeah, can you just check it out? It's out of these someone. Which one is it? I forgot. It's not 4, then which one is it? Yeah, I think it's question number 5. Can you try question number 5, girls? No,
So
again?
last time we had a question and we did everything, we got a different answer.
Yeah, but now you will do that because that's what the trick is actually. You know what we did? We placed the n value wrong. Now here they say that the third minimum. Now which value shall you put it here? N value.
4 no 3 no 2.
2. Because your 1 is actually starting from 0 here. They didn't say that. They say third fringe. Third fringe will be 0, 1 and 2 because we have to consider the 0 in that as well. As far as, yeah.
Is the what's it called? How do you convert micrometers to meters? Is it times 10 to the power negative 6?
It is. It is.
Is it 6 times 10 to the power negative 7?
Oh, okay. Let's check it out. Now, can you convert it into millimeters then? 0.00 something something.
I got the same 6 times 10 to the power negative 7.
Okay, let's check this out. Yeah, but they write it 600 nanometers. What is your answer, by the way?
Wait.
What is the value? 6 into 10 raised to power?
6 negative
Negative
7.
7?
Negative 7. So actually, if you increase the negative values, you have to actually move the 0. So it will be 600 into 10 raised to power minus 9. So we are at the right track. 600 nanometers. Yes, Manu, now you understand what was the mistake actually?
Yes, yeah.
So always remember, in case of dark, you have to consider everything from 0. In case of bright fringe, it will be starting from 0, but it will be considered 0 order, first order, second order. But here in the dark fringe, we do not say 0th order. We always say first order, that is the 0, n is equal to 0. That is a small catch in the question. Otherwise, everything was right. Okay. Now let's do some further question and then we leave this topic and jump to diffraction grading. All right. This question, which is at the end, they say using the result problem above, calculate the distance between the fringe. Okay. What is the result they're asking? Forget about the result. The formula we have it, that is, uh, what was the formula we have just written for delta y? Capital D lambda upon small d. We have just derived the formula a few minutes ago. That was delta y equal to d lambda. Remember that? Okay, yeah. And this is small d. Now the question is saying it, calculate the distance between for fringe 33 nanometer light falling on a double slit separated by 0.0800 millimeter located 3 meters from a screen as shown in the figure. Can you find me the value, please? Yes, I.
And 10 o'clock.
Okay. Okay, girls, I just. Okay. Did you find that?
I got
Yeah, we got
0.02.
different orders.
Okay. What's the value
I
for
got
both?
0.024.
Okay.
Same.
Okay. One value is, I don't know which one.
Yeah, that's the same answer we all got then.
Okay. So you got the answers, right? So everything sorted, understood?
Yeah.
Yes.
Okay. Let's jump to diffraction grading, a new topic, a small topic, and almost the same one. No difference. So where is it? Let me just check if it's there. Diffraction grading. Okay. Diffraction grading is here. Now, absolutely same formula, everything same. So what is the difference then? Let's check this out. This is first of all a single slit diffraction. Now, first of all, what is meant by diffraction? We have done this in IGCSEs or GCSE or whatever at Excel. What exactly is mean by that? Any ideas?
Diffraction is the bending of light.
Yes, it's a bending of light from the edges, sharp edges. Or sometimes we also call it that it's a spreading out of the waves from the sharp edges or from the obstruction, you can say that. So point is, if you just check this out, this is a wave front, right? This is a way of expressing a wave. Two parallel lines. Two parallel lines means one wavelength, a complete crust or trough in here. So basically, if you check this out, when this wavefront is passing through this, actually they change into some sort of a curve wave. Can you see that?
Yeah.
Now,
Yeah.
important thing is very much important in here. If this length, or you can say this aperture wavelength is less than the wavelength, or in other words, this is very, very sharp, you will get more and more circular waves. If if this length or this aperture is bigger than the wavelength of the wave, then you will get that type of waves at the output. So as this particular distance increasing, that spreading out will be reduced and reduced and reduced. Okay. So basically, spreading out is all depending upon that distance. That distance should be as sharp, as small as possible. Remember that. If possible, that distance should be as smaller than the wavelength of the wave you are using. So it means that should be so sharp that light can easily pass through and give you a round, a spread out thing. Can you tell me the practical application for that? Anything which is practical, which you see in your daily life somewhere.
Um, what's it called? Signal towers? Oh,
No, no,
what
no,
do you
no.
call them?
Do you know that blinds thing? Do you ever went through the blinds?
Yeah. No, wait. Oh, no, no,
What
I
is it?
don't get
What
it. Blind.
you don't know what blinds are? Let me show you the blinds. Then you will
I'm not
understand that.
sure which one you're talking about.
Okay, okay. Let's see. Let's see what blinds are. I'll show you. Normally, the blinds are some sort of curtain, but it's a
Oh,
special curtain
oh,
which saves you from, direct sunlight. But blinds, BLINDS. Now, what are these things? Let's check. Not binds, blinds. Let me show you the blinds. These are the blinds. Most of the time, but we believe that this is a sort of a uh, design or something. This is normally we see it on the windows. Can you tell me why this is on our windows? This sort of design or something? These are our blinds and everything. It actually saves us from direct sunlight. When light comes from these small blinds, actually the intensity of the light coming from the sun is reduced. That is the purpose of these blinds. We have it. Now, our thinking is always that we make these blinds as sharp as possible. The distance between each blind should be as small as possible. In that case, the intensity of the sunlight which is coming through or which is coming in our room is as small as possible. This is one of the practical applications of this diffraction phenomenon. Right? Everyone now understand that?
Okay.
Now,
Yeah.
I will read something until I'm reading it and I will explaining. I want you to write that as well. So diffraction is usually represented by wavefronts as shown by the vertical lines in the diagram. The only property of the wave that changes when it diffracts is its amplitude. Remember that frequency will never change. Only and only amplitude will change. Not even a wavelength is changed. Only the amplitude. Amplitude means the height, the displacement. This is because some energy is dissipated when the wave is diffracted through the gap. The diffraction pattern of light can be represented as a series of light and dark fringes where it shows area of the maximum and a minimum intensity. Just copy that first and then I will explain what exactly they are saying.
But you kind of explained it before that the blinds can change the intensity, so the changing the amplitude is like changing the intensity.
Yes, that's what it is. Amplitude changing means intensity changing. Because we also studied in IGCSE that when you're talking about intensity of thing, we are talking about the displacement or amplitude of the things. When you're talking about the pitch of a thing, we are talking about the frequency of the wave or so, whatever we are talking about. Okay. Everyone understood?
Yeah.
Because on the basis of
Yeah.
that, this all diffraction grading will be. The formula will be same, nothing changed. Only one thing will change and you will find out what exactly it is. After finishing that, please, I want you to go through, before coming to the class, just quickly go through to the photoelectric effect, because photoelectric effect is very interesting, but it's a very time consuming as well. A long topic along with the de Broglie waves. Because now after finishing this topic, we will be jumping into EM. This is the first topic before actual EM will start. And it's all theoretical, a new thing. Some topics are old, but one or two topics are new in that. So it's incorporation of new and the old.
Hello?
Yes. You copied?
Yes. Yes.
And what about the other two, Alicia and Manur?
Yeah.
Yes, sir.
Okay, let's move on now. Now let's check this out. What exactly is happening? Now, once we understand that that thing is happening, now if a laser emitting blue light, let's suppose, is directed at a single slit. Now, instead of sending it to double slit or something, we are sending it through the one slit. Now we know that once we send it through the one slit, it will be diffracted, right? Where the slit width is larger than the wavelength of light, it will spread out as following. Now, what they're saying is, if where the slit width, this width is larger than the wavelength, it will do like this. Now, this is the wave. This is sort of a bright fringe at the center. All the other fringes are smaller in size. As we proceed further and further and further, you will find smaller and smaller and smaller fringes. Or in other words, the intensity of the waves become smaller, smaller and smaller. Very simple, constructive interference and then this intensity become, added with the path difference. It's the same thing what we have done in young double slit experiment. Initially, why the highest intensity we got it? Because the path difference is 0. Then path difference got increased, and as the path difference increased, it will be a constructive interference. It will be a constructed interference, but it will be shorter and shorter and shorter. Okay. Now, if you see that features of the single slit diffraction patterns are a central maximum with the highest intensity, subsidiary maxima equally spaced, successive smaller in the intensity, and half the wave width of the central one. So, basically, if you just check this out, that is the diagram we have it. It's the same double slit, but only difference is this one is an example of a diffraction rather than previous one is also an example of a diffraction, but that one is a bit different than this one. This is one slit, that one is double slit. Copy that, whatever is written here. So now check further in this, which is very, very important. If the laser were to be replaced by non-laser source emitting white light, now remember that in that case, you will have multiple spectrums because light will break. The central maximum would be white. All the maxima would be composed of spectrums, and the shortest wavelength, violet blue, would appear nearest to the central maxima. The longest wavelength, red, would be appear furthest from the central maxima, and the fringe spacing would be smaller and the maxima would be wider. Now, what exactly it means, first write it and then we will explain it in details. Now, once we understand this all basic things, let's see the diagram here. See, initially we were talking about a monochromatic light, right? Now, if it's not a monochromatic light, it's a white light, then you will have a white, the most intense light or the most intense, what you call the wave will be at the center, and the rest will be a mixture of different lights. Okay, so that's the reason we normally do not use this what you call this white light, rather than we used a laser light that will help us to find out our results very easily and we can easily recognize them. But we do use white color light as well, but not at your level. It will be a bit different when you use it. Now, this is important. Here, wavelength is smaller than the gap. Here, wavelength is greater than the gap. I told you previously, if gap is smaller than the wavelength, then and only then this single slit diffraction occurs. If this is the case that wavelength is very, very smaller than the gap, or in other words, gap is very, very big than the wavelength, then this experiment will not be performed, or you will not see the pronounced effect of that. So as discussed above, the effect of diffraction are most prominent when the gap size is approximately same or smaller than the wavelength of the wave. If it's bigger, then definitely one time will come that there will not be any diffraction. Or at least if you have a diffraction, that it will be a sort of a straight line if you just see it here. Okay. So please draw these and write this description. Any problem in understanding that till now?
No, sir.
No.
Good.
No.
Good. I'm trying to make that thing in more detail so that you understand the details, so that things will be piece of cake for you. I believe every one of you understand young double-sided experiment well. What about you, Mahanur and Alicia? Let's move a bit and then we will stop at one point. I'll tell you when. Okay, now if you see that patterns are like this. So intensity pattern of red light shows a longer wavelength, diffract more than the shorter wavelengths. Okay. So basically, if the slit was made narrow, the intensity would decrease. If the fringe spacing would be wider. So this is what the intensity pattern of the red laser will be. So when wave is traveling through the air, which scenario best demonstrate the diffraction? UV radiation through the gate post. Okay, this is D actually. X-rays passing through the atomic in a crystalline solid. For the time being, just need to understand one thing. Intensity pattern of red light shows longer wavelength, diffract more than the shorter wavelengths. So it diffract more than the shorter wavelengths. If slit was made narrow or thin, you can say, the intensity would decrease. If the fringe spaces would be wider, the fringe spaces would be wider because the spreading is more. So more spreading is directly proportional to the width, but inversely proportional to the intensity. Remember that there are two things. Simple means is if the distance is narrow, spreading is more. If spreading is more, fringe spacing would be wider. And the intensity would be reduced because it is directly proportional to the slit size. Okay? Understand?
So
Yeah.
the slit the slit distance is directly proportional to the intensity,
Not distance.
and
Distance and I mean slit size. Because here there is only one thing. Like if you have a gap, right? So you're talking about this slit size, this one. When you say slit distance, it made you're talking about two slit distance like that. Here it's not distance we count it. We count it slit size, only one. If it's smaller, then you may have a wider fringe spacing, but intensity would be smaller. Okay.
okay.
So I think we better stop it here. Inshallah, we will be continuing from here in the next class. Okay. So see you then. I will upload this video right now. So you can see through the video if somebody you do not understand or anything, any problem anyone has.
Okay.
Okay, then take care.